This conference will now be recorded.
So let's start with the session now. Uh, okay, so now we'll start with the AXI protocol. AXI protocol stands for Advanced Extensible Interface. AXI protocols falls under a category of protocols called as AMBA protocols. Okay. So we'll be discussing all the aspects of AXI protocol. We'll also be working on the verification IP development for AXI protocol. So first, let's start with the protocol overview. If you remember, during our Verilog training, we have learned a protocol called as APB, which is Advanced Peripheral Bus Protocol. During that time, we discussed that protocols are two categories. One is on-chip protocols, one is peripheral protocols. The on-chip protocols are like APB, AXI, AHP, OCP, PCI. See, it's not PCI Express, it is PCI. These are all examples of on-chip protocols. Majorly, they are limited by the frequency of operation. I mean, when you work on on-chip protocols, you have to work at a limited frequency. I mean, as soon as you increase the frequency of operation, it results in some timing issues, setup time violation kind of issues. And in case of on-chip protocols, the data communication happens in terms of transactions. Like for example, it will be like arbitration phase, uh, address phase, data phase, response phase, and handshaking. They will involve all on-chip protocols involve handshaking using dedicated signals. Can someone tell me what is that we used for handshaking in APB protocol? What signals were used for handshaking in APB protocol? We used P enable and P ready. It's not valid. It's enable. P enable and P ready. Okay. Talking about peripheral protocols, examples are like USB, PCI Express, SATA, SPI, I2C, UART, HDMI, and VGA. They are limited by the number of ports. Data communication happens in terms of packets or frames. Either packets or frames are used for data communication. Here it is transactions. In case of on-chip protocols, they are called as transactions. For example, in APB, we used to call as APB transaction. We didn't call as APB packet. Whereas when you come to USB, you call it as USB packet or USB frame. In peripheral protocols, handshaking happens using preamble or sync. There will be some patterns called as preamble or sync to do the handshaking. Receiving device uses symbol preamble to understand that packet is starting. Basically, preamble will tell that a packet is going to start. For example, receiving device uses preamble for packet detection or sync pattern or to start a packet detection. Receiving device, yeah. I hope you got the basic idea about what is the two types of protocols. Now, generally protocols are differentiated based on four factors. One is what features do they support? What is the performance you get out of it? What is the power consumption? What is the pin count and complexity? And overall pin count, complexity, and the cost. Complexity and cost. Basically, our goal is to, I mean, if given a protocol, we want a lot of features, lot of performance, less power consumption, in cost. Okay, AXI falls under a category where it gives just give me 1 minute. Is it fine now? Is my audio fine now? Am I audible? Okay. Okay. See, what is special about AXI is uh, it supports a lot of features basically. It supports something like out of order transactions, overlapping transactions, cacheable transactions, secure transaction. I mean, whatever you see here. So let me write down what all things AXI protocol supports. Okay. Let me write here. AXI supports various features like, as you see here, all these features it supports. Basically, it supports features like out of order transaction, overlapping transaction. More of this we'll discuss as we go forward. Right now, even if we read through this, you won't be able to remember them. AXI is among the protocols which supports maximum number of features. Next, as you see, AXI falls under a category of protocols called as AMBA protocols. See, AMBA stands for Advanced Microcontroller Bus Architecture. So it is a family of bus protocols. Family of bus protocols. So what is all there in the family? APB is there, ASB is there, ATB is there, AHB is there, AXI is there, ACE is there, CHI is there. So totally how many protocols make the AMBA family? Can someone tell me? How many protocols does AMBA protocol family has? Totally it is 7 protocols. So in these 7 protocols, as you move in this direction, when you go from APB to ASB, the performance will increase. So this will give you more performance compared to APB. Similarly, this will give you highest performance. So in this direction, if you go, performance will increase, power consumption also increases, cost and complexity also increases. So APB gives you the lowest performance, lowest power consumption, and it involves lowest cost. Okay, I hope you understood this order, right? APB, ASB, ATB, AHB, AXI, ACE, CHI. Where these protocols are used. Basically, question comes, why we need so many protocols? In AMBA itself, why we need so many protocols? Why can't they use only one protocol, or why can't they use 2 protocols? I think the reason is it is to fit into different requirements. See, different protocols have different requirements. Different designs have different requirements. So AXI and AHB are used in ARM processor interface with external world. When ARM processor wants to interface with external components, AXI and AHB are used for that. All ARM processors are RISC processors. They are all based on RISC architecture. ARM family has 3 types of processors. I mean, whenever you say you are working on ARM processor, it will be one of the 3 types. One of the 3 types. One is called as A series processors, R series, M series actually. Okay, these are the three series: A series, R series, M series. Let's understand. A series means application series. A stands for application, M stands for embedded, R stands for real time series. Okay, so if you take your mobile phone, the processor that went into your mobile phone is the A series application. So this is a very high performance processor. You take in your house, let's say washing machine is there. What went into washing machine is a M series processor. You see, you come across uh, auto driving cars, right? Auto driving cars. In that, real time processor will went because it needs to time analysis of the data, images, processing where, I mean, what is coming in the opposite direction, is there any obstruction, all those things is processed by the R series. Okay. Can someone tell me what goes into your mobile phone? What type of processor? Can you tell me what goes into a mobile phone SoC? What type of processor will go into mobile phone SoC? A series processor, application series. What goes into your microwave oven? Let's say in your house there is a microwave oven. What processor went into that oven chip? See, oven also will have a chip, right? That will be M series because they are applicable for embedded medium performance processors. Now let us read this ones. A series stands for application series. These are high performance processors. AXI is used as processor interface to the rest of the system. Basically, A series processors are based on the AXI. Examples are like mobile phone SoC, laptop SoC. What goes into M series? M series is embedded series. These are medium performance processors. They will give medium performance. Because it is medium, we'll use AHP. What is an example? Washing machine and microwave oven. Third is R series, real-time safety critical application processors. Like real-time safety critical means what? Like the auto driving cars and all those things. Here also HB is used. These are used for automotive applications. Okay. Next, uh, what is meant by performance? I have been talking about the term performance. What exactly performance refers to? Performance refers to in a given amount of time, how much maximum data can be transferred. What is performance means? In a given amount of time, that is in specific number of clock cycles, how much maximum data can be transferred is what indicates the performance. If I take APB, let's say I'll give you one question. Can you please do that, everyone? I'm using APB protocol between master and slave. I have a master, I have a slave. This interface is 32-bit data bus. A PW data is what? 32-bit. Okay. Each uh, each transfer, APB write write transfer requires 2 clock cycles. How many clock cycles are required to transfer 100 bytes of data? Not 100, yeah, 100 bytes of data. Can you tell me, using these calculations, can you tell me each APB write transfer will take 2 clock cycles? So how many clock cycles are required to transfer 100 bytes of data? Can you please give this answer, everyone? Yeah. Yeah. Can someone tell me how many clock cycles are required? See, it is 32 bit. If it is 32 bit, what will happen? One transfer means 4 bytes, right? Because 32 bits. And one transfer takes 2 clock. How many bytes you want to transfer? 100 bytes. Now, can you tell me how many clocks will be required? Can you tell me how many clocks are required? It will be 50 clock cycles, right? Because it's a multiplication factor of 25. Here also you have to do multiplication factor of 25. So basically, so in case of APB protocol, to transfer 100 bytes of data, you will require 50 clock cycles. Going forward, when we study AXI protocol, we will understand that to transfer same 100 bytes in AXI protocol, it will roughly require 26 clock cycles. So which is more efficient? AXI protocol is more efficient or APB protocol is gives more better performance? Which protocol gives you better performance? AXI gives more better performance, right? So that is about briefly about performance. Okay. Now, going to the AHB. See, when you go to AHB, AHB uses concept of pipelining. AHB uses a concept of pipelining, which ensures that the current address phase and the previous transaction data phase happens on the same clock edge. See, when we go from APB to AHB, APB to AHB protocol. I mean, when you take a new protocol called as AHB, the AHB uses pipelining. What is pipelining is, I'll give you a briefly. If this is the address bus, let's say, if I take one of them as the address bus, let's say this is the data bus. So first time when you want to do the transaction, you will do the address space here, right? You did address space. For this, the data phase will happen here. Data phase will happen here. While you are doing it, in case of APB, what you used to do is, see, these are like the clocks. These are like the clocks. Okay. In case of APB, understand, in case of APB, the next transaction has to start here and the data phase will happen here. Then address phase, data phase. This is how APB works. Understand? The APB protocol works in this way. Whereas the AXI protocol, AHB protocol, let's take AHB protocol. How AHB protocol works is, the see AHB I'm showing in the green color. The data phase will happen here itself. The data phase will happen here itself. And address space I can do here itself again. So I don't have to wait for this much, because I've finished the data phase. I can do the new address space. Here I can do the previous transaction address space. See, understand, corresponding to this I'm doing the data phase. There's a mistake. This is the next address space. Corresponding to this is the data phase. While I am doing the transaction 2 data phase, I can do transaction 3 address space. So both will happen parallelly. Did you understood the difference? Because of this, what happens is, to do 25 transactions, overall it will take 25 clock cycles, and plus one clock cycle you gave initially. So totally how many clock cycles? It will take 26 clock cycles. Let me draw it again and show you so that you are clear with this. What are we talking? So if this is the clock, in case of AHB, first you did address space here. First you did the address space here, A1. Corresponding to that, here the data phase will happen, D1. But while it is happening, I can do A2 here already. I mean, I don't need to wait for this to complete and do here. Here I can do D2. Then I can do A3. Here I can do D3. So this concept where both happen at same time is what we are calling as the pipelining. Did you all understood what is pipelining? Have you all understood what exactly is pipelining is about? Let me just draw in a clear manner. So here you do A1, address 1. So here you will do address phase 1, address 1. Corresponding to that, you will do the data phase 1. Here you will do at the same time, same edge of the clock, you will do address for transaction 2. In the next clock edge, corresponding to this address 2, you will do data 2, transaction 2. Next, you will do address 3. Corresponding to this, you will do data 3 here. Okay. And here you will do address 4. Here you will do data 4. This concept where we are doing uh, parallelly, things parallelly. This concept is called as pipelining. Have you understood what exactly is pipelining means? Now, using pipelining, it will take how many clock cycles? Tell me. Can someone tell me using pipelining how many clock cycles it will take to transfer 100 bytes? So using pipelining, it will only take, by using concept of pipelining, takes 26 clocks to transfer 100 bytes. Whereas, how does it differ in APB protocol? So this is AHB protocol. How does it differ in APB? Can someone tell me what will be the difference in APB? In APB, address and data cannot happen at same clock cycle. While data is happening, nothing will happen in the address space. Because of that, all it will take 50 clock cycles. Is that clear to everyone? How we came up with this number? Talking about AXI, now you may say, what more can you do in AXI protocol? Whatever you could do, whatever improvement you could do, you have done in AHP. What more can you do in AXI? See, in AXI, what happens is, in AXI, this address space itself won't be there. In AXI, what will happen is this address face itself won't be there. Address face itself is not sent. Address information is sent only once at the beginning of the transaction. Because of that, what will happen? Your protocol efficiency increases. Your protocol efficiency increases. Do you understand why it will increase? Because not the efficiency, power consumption will increase. The power efficiency will increase. Reason is you don't have to drive the information multiple times. So uh, hence that transitions won't happen. Because of that, overall performance will increase. Is it clear to you how this AXI is differing now here? And how many clock cycles AXI will take as per this? This improves the power, this reduces the power consumption. But then to support it, slaves should be intelligent, because slaves should do this calculation, right? What does data 1 corresponds to, what does data 2 corresponds, what does data 3? Slave should do all that calculation. Slave should be intelligent enough to calculate the next address where the data should be stored. Slaves should be intelligent to calculate the next address and how to handle the next transaction, everything. AXI has concept of ID to support concept of ID. AHB and APB don't have it. AHB and APB don't use ID concept. I hope you understood. Now, see, this is an example where AXI protocol is used. This whatever yellow color you see, do you see yellow color? In most of these places, AXI will be there. The whole yellow color thing is what is AXI in this diagram. This will be working on AXI. I would rather say this is AXI for sure. To that, everything is connected, because it is a common thing that is connecting everything, right? It should be high performance. We should use a high performance protocol here. Any questions so far? Okay. Okay. Let's correlate AXI with the APB protocol. Okay. Let's correlate AXI with APB protocol, because we already know APB protocol. So based on that, let's understand what other updates are happening. See, we already know APB protocol, right? Can you please list down the signals in APB protocol, everyone? Can you please list down what all signals are there in APB protocol? Okay. So I hope you have listed down what signals are required. P clock, P reset, P address, PW data, PR data, P write, P enable, P ready, P selection, P error. APB implements all the writes and read transactions in a single channel. Basically, APB has everything goes into single channel only. APB only supports single write and single read. Whereas when it comes to AXI also will require these signals. It also requires additional signals to support more features. Because AXI supports more features, to support more features, it requires additional signals. More importantly, AXI implements. So what are the major differences? Uh, AXI implements write transactions using three channels, three different channels. See, here we used only one channel. Understood? Here we used only one channel. Whereas here we are using for write, there are three different channels. For read, we use three different channels. Whereas read transaction uses uh, two different channels. So totally AXI has five channels. AXI totally has five channels. Uh, so that is one primary difference that you need to remember. Our focus area will be, our focus will be on understanding. We'll focus on understanding what new signals are required to support more features. What is the benefit of having five different channels? To understand that, let's understand the concept of channels. How, what is benefit of channels? Benefit of multiple channels. So you take a simple analogy. We'll take. FM radio. Are you all familiar with FM radio? Okay. So in your city, how many FMs are there? Typically, how many FMs are there? Around, let's say, five FMs are there in your city. Okay, five multiple FM channels will be there. What happens as a you? They are all these channels carry different information and happens parallelly, comes as a concurrent data. Basically, your radio is tuned to collect all these, to extract information from these channels. So the advantage is, what is the advantage of having so many channels is, advantage of multiple channels is they are able to transmit lot of, multiple things concurrently. Do you understand that? We are able to get a lot of concurrent information parallelly. Lot of details are coming parallelly, right? What if there was only one channel? Tell me. See, it's like example is what, if you want, you can listen to example. You can listen to Hindi song. Okay, you can listen to some other anything, right? Different things you can do just by changing the channel. That is because the data is being transmitted parallelly. Okay, what if we had only one channel, in the song or any other program, etc., right? What if we had only one channel? So what is that you can do? Can we listen to multiple programs at same time? No, right? All information need to be sent in one channel only. So this becomes one channel becomes a limitation. Okay, one channel removes the possibility of concurrency, possibility of concurrent data transfer, information transfer. This is what even AXI does. See, APB uses single channel. AXI uses multiple channels, means 5 channels basically. That makes the protocol efficient. It brings in a concept of concurrency, which helps with doing multiple transactions concurrently. See, even in FM radio, channels are independent, right? See, whatever is happening in 98.2 won't affect 101.3. All those channels are independent. So this is how AXI also work. One transaction will not impact the other transaction. One transaction on in a channel will not impact transaction in other channel. Okay, right? Did you understood what is the benefit of having multiple channels? Next. What new signals are required to support more features? See, in summary, I told you, right? AXI supports more features compared to APB. So to support more features, you need more signals. What are those? To support more features, you need more signals. So what are those? Support more features, we need more signals. So what are those features? What are those signals? Let's write down. AXI supports burst transfers. AXI supports burst transfers. Let us understand what exactly is a burst transfer. Are you familiar with the term burst transfer? Okay, let's understand it once. Uh, address is issued once. Address is issued only once. Data phase is done multiple times. So this is an example. See, you're sending address only once, but data is corresponding to that data is sent multiple times. It means what? Let's say this is a 4-byte data bus. If address is 100, hexadecimal 100, first data will store into 100, 101, 102, 103. Second data will store into automatically. Slave will understand next. See, because I'm done 104, 3, 105, 6, 7. Next data will go to 8, 9, A, B. So this concept where you issue the address only once, data is sent multiple times, is what we call as the burst transfer. Did you all understood what exactly is a burst transfer refers to? Okay. Next. To support burst transfer, what details master should tell to slave? I mean, what is that slave should be told? What details master should tell to the slave? These are the 3 details it should give. Can you please read it once? Please read it. So AXI support burst transfer. As I said, burst length is what? Number of data transfers in the transaction. So what is number of transfers is, let's say you are doing 1, 2, 3, 4, 5. Let's say you are going to do 8. So the burst length will be 8. That number is called as how many times you are going to send the data is what we call as the burst length. What is burst size? Number of bytes sent in each transfer. See, each time, are you sending 4 bytes? Are you sending 8 bytes? Are you sending 16 bytes? That is called as burst size. Next thing is called as burst type. How the data should be stored in the slave memory. What is meant by burst type? How the data should be stored in the slave memory. See, when slave memory, slave, slave means what? AXI slave gets the data during writes. How it stores information, stores these bytes into its memory. It's called as burst type. More about burst type, burst size, burst length we'll discuss as we go forward. The one more feature is the concept of AXI features. Is the concept of out of order, overlapping transactions, etc. I mean, I'm just giving a brief about what is what. Let's understand them. The AXI supports out of order, overlapping, and interleaved transactions. It supports various types of transaction. To support them, AXI introduces a concept called as ID signal. It uses a concept called as ID. What ID signal is used is basically ID signal is required to support all these features, to support all these things. Each transaction, write or read, is assigned with a unique ID. All the phases of transaction happen with that unique ID only. So let's understand this concept of ID. Um, what is the concept of ID in Excel? What is ID in Excel? To understand that, let's take a simple example. You see, let's say you want to construct a house. Let's take analogy. You apply for a home loan. You apply for a home loan. Tell me typically how much time home loan takes. Can you tell me the whole process of applying home loan and getting the loan? How much time it takes roughly? Let's say it takes 1 month time. It takes 1 month time. So what is involved there? Application phase. You apply. Document submission phase. Then sanction phase. How many applications will you give? Will you give one application or multiple applications? To apply for a home loan, what will you do? Will you apply? Will you give one application or multiple applications? Only one time, right? One time. This is similar to address space in Excel, which is done only once. Coming to document submission phase, how many times do you submit document? One time or multiple times? Generally, does document submission happens in one time or do you need to do multiple times? It generally happens multiple times because they don't they will keep asking, I need this document, I need this document. So it happens multiple times. So this is again similar to data phase in AXI, which happens multiple times. Example is this: document 1, document 2, document 3, document 4, like that. You submit multiple documents. Okay. For each document submission, they will say, yes, I received this document, I received this document, like that. Finally, once you submit document, what will happen? You applied, you have done the application, you have submitted the documents. What will happen? They will either sanction the loan or they'll either reject the loan. So that is the response phase. Happens only one time. Am I audible now?
Yes,
Hello
sir.
everyone. Am I okay?
Yes.
So I was talking about uh, so in this loan example, since you are doing different things at different times in the 1 month, to track a loan process, the bank will assign an application number. Bank will assign an application number which is unique to you. No one will use that application number. Whenever you do application, whenever you submit document, whenever sanction happens, it happens specific to that application number. Same is the concept of ID. Same is the concept of ID in AXI protocol. In AXI protocol also, the ID is used to track the transaction. See, address phase, data phase, and response phase happens at different times. So to make sure that they don't get mixed up. See, if you don't use application number, what will happen? I can take someone else's document and my bank may assume someone else's document as my document because I'm not using any number. So to avoid that confusion, what bank will do is they will use the concept of application number. By using application number, whenever I submit my document, I will write in on the top of my application number, document, I'll write my application is 1375, for example. So all the things will happen with respect to that application number. So whenever the bank receives any document or anything with respect to 1375 number, I know that it knows that it is specific to my home loan only. Someone else home loan will use a different number. Instead of 1375, they will use some other number, let's say 1729. So all their documents will be using 1729. So similar is the concept of ID in the AXI protocol. So when multiple transactions are happening, let's say you see here, it is only one transaction. So it may be possible that while this transaction is happening, I can do one more transaction, one more, a different data phase, different data phases. So they all can get mixed up. How does the master and slave identify what is what belongs to whom? That is by the means of ID. Even in the bank, when the bank gets different applications, different documents, everything, they will use that application number to identify everything. Is this all clear to everyone? Next, AXI adds signals like lock, cache, and protection. AX, basically in summary, AXI is nothing but APB plus everything else. APB plus other signals. Understood, right? AXI is nothing but APB plus burst length plus burst size plus burst type, uh, the ID plus lock, cache, protection, and AXI specific handshaking signals. All these signals implemented using 5 different channels. All these signals are implemented using into 5 different channels. Did you all understood? Everyone clear till this point? Okay, next. What is the need for 5 channels? Let's understand. Okay. AXI protocol. It allows 5 different transactions to happen at same clock edge. AXI allows 5 different transactions to happen at, I mean, it will allow, now whether 5 different transactions happen or not, it's a different thing. Basically, it allows multiple transactions, rather I would say, multiple transactions to happen concurrently. Okay. So what does it mean? Let's say I'm doing a write transaction. During the write, in the write address channel at time 0, a transaction A write address phase is happening. In the write data channel at same time, at same 10 nanoseconds, transaction B write data phases can be happening. In the write response channel, see there are 3 channels: write address channel, write data channel, write response channel. At same 10 nanosecond, a different transaction write response phase can be happening. You see, at same edge of the clock, 3 different write transactions are possible. Same thing with read also, because all of them are independent channels. It's like I told you, right? These are 5 different channels of the radio FM. So they can be, one can be carrying one information, other can be carrying other information. So like that, all of them can happen concurrently. So how to make all these channels independent? So how do you, when so many channels are happening, so many channels are there and they're all doing the transactions concurrently, how do you make sure that they become independent? So dedicated handshaking signals are used for each channel. Every channel has its own set of handshaking signal. So total of 5 pairs of handshaking signals are required. A total of 5 pairs of handshaking signals are required. Clear to everyone? What is the how the having 5 different channels will help? It's in simple terms. In simple terms, if this is master, this is slave. In APB, what you used to do is this all the information like P address, PW data, PR data, everything we used to call as one channel. When it comes to AXI, the same thing will divide. One is write address channel, one is write data channel, one is write response channel, one is read address channel, one is read data channel. So like that, 5 different channels will be there. Next, since AXI protocol supports write and read transaction to happen concurrently, each of these channels require their own dedicated signals. I'll rather call it as AXI channels. Each of these channels requires their own dedicated signal for everything. Like burst length, specific to write and specific to read. Does it mean AW length and AR length are 2 different ports in AXI protocol? So AXI protocol has 2 signals for burst length, one for write, one for read. Same way, there is one for burst type. We'll have one more variable called as burst type, one specific to write and one specific to read. So one is called as AW burst, one is called as AR burst. Then address specific to write and read. So there will be AW address and AR address. Understood? See, every signal gets duplicated. There will be AW length, AR length, AW burst, AR burst. So this will go into one channel, this will go into a different channel, like that. See, all these signals make one channel, these signals make one channel. This concept of 5 channels, dividing everything into 5 channels, allows for doing 5 different transactions concurrently, which results in an improved bandwidth of AXI protocols. Because they support concurrency, it results in the improved bandwidth of AXI protocol. Let us list down what all ports are required in AXI protocol. This is like a repetition of what we have discussed so far. Can you please read this once, everyone? Please read it once. So APB has these signals. Okay. Moving to HB protocol, P is changed to H. So P address becomes H address. In HB, it's called as H address. So AHB adds new signals to support additional features of HB. Support additional features, AHB adds new signals. Since AHB is only one channel, naming convention is uniform. In AHB, everything is again one channel only. Naming convention is uniform, everything starts with H. Whereas in AXI protocol, signals are classified into uh, 5 different channels. Write transaction, read transaction channels. The write transaction, how many channels are there? Can you tell me?
Two channel.
Write transaction has 3 channels. Read transaction has 2
Okay.
channels. Okay.
Okay.
So write address and control channel starts with AW. Write address and control channel. It is called as rather I will say write address channel. So that for simplicity. Okay. Whether you keep it or not doesn't matter. Write address channel uses AW. Write data channel uses W. All the signals in this channel starts with AW. Understood, right? All the signals in this channel, write data channel starts with W. So on. Clear to everyone? Is this clear to everyone? How AXI 5 channels will start with different names? Next. What are the new signals required in AXI protocol? I have told you, right? Already burst length is, please read it once. What is required? We'll discuss about, see, you know what is burst length, what is burst size, burst type. We'll discuss about other things as we go forward. Okay. Now let us understand how does the right channel work. To understand this, just take a very simple example of home loan. Just to understand this, take an example of home loan. It is like, this is when you started. First you gave what? Tell me, what is that you do in the home loan very first thing?
Provide application.
So that is like right address channel is like the providing application. You're applying here. Once you applied, what is the next thing you will do?
Documents. Document
So you're
submission.
submitting multiple documents. Once the document submission is done, what they will do? Tell me.
Sanction or not.
Sanction. So what is happening is, so who will submit the application? Will the bank give application to you, or will you give application to bank?
We will give application.
We will give. So you are like the customer. This is like the bank. So that is, what is the direction of address space? Tell me. Address channel information goes from where to where? Address channel information goes from which component to which component?
From initial to responder.
From master to slave. Where does the who will give write data channel information, master or slave?
Master will
Write
give
data will again
data.
go from master to slave. You can see these directions. Can you see? Who will sanction? Will you sanction the loan to bank, or will the bank sanction loan to you?
Bank will
Bank.
sanction.
So response will come in this direction. So right response is given by the slave. So if you see this diagram, address and data information is given by the master, response is given by the slave. So is this diagram clear to everyone? So write address phase only once, multiple write data phases, and one single response phase. So transaction involves multiple transfers. In this case, transaction involves what? Multiple transfers. Any questions so far? Okay, next. Next. Talking about write read channels. How many channels are there in read transaction? Can you tell me? Read transaction has how many channels? Two channels. What are those channels? Read address channel and read data channel. So that is what you see here. So there is a, you in read case also you give the information. You have to give the address and control. Master will give, but slave will give the data. In read transaction, single read address phase, multiple read data and response phase. So transaction involves multiple transfers. Any questions so far? Clear, right?
Sir, all these protocols are used are on the base of memory type only. Means the object will be
Are
of memory
based
type only.
memory type only. Yes. The slave will be like a memory always.
In always any
Yeah.
protocol APB, AHB or AXI.
Yeah.
So, sir, what type of memory means? What exchange is done? What is the need for
I
these
will
protocols?
when we discuss further, you will understand. Okay. Let's as we go forward, you'll understand what happens.
Okay, sir. Okay.
It's like the memory that we discussed during Verilog training. What happens when you perform a write into memory? Whatever data you give, that gets stored into the memory. When you perform a read, what happens? There is a memory present here. So the memory, whatever data, based on what address you gave, that location is read and that data is returned here.
Hmm.
Only difference is when we studied memory in Verilog, the data was coming only once. One address, one data. Here, it is coming multiple times.
Yes.
Okay. And
Yes,
now,
sir.
someone has a question like, what is burst type? I'll explain burst type later. Right now, let's not discuss that because as we go forward, at the right time, I'll explain you that. So let's now understand what is AXI transaction. AXI transaction is nothing but request plus response. When I say AXI transaction, it involves request and response. Put together is what we call as a AXI transaction. Okay. So first one is write transaction. What happens in write transaction? Tell me. Master gives write address request with address and control information. Then who will give the data, write data? Master gives or slave gives? Master, master gives write data. Think simple, very simple. Master gives write address and control information. Master gives multiple write data phases, write data phases. Okay. Slave responds with write response phase. Slave responds with write response status. In case of read transaction, master gives read address and control information. Slave gives read and data response in response data phase. Read data phase. Clear to you? Next. Please read this once. We have already discussed about AX channel. Please read it once. Write address channel starts with AW. Write data channel starts with W. Write response channel starts with B. Read address channel starts with AR. Read data channel starts with R. All common signals will start with A. See, clock is a common signal. Reset is a common signal. Starts with A. A clock, A reset. Okay. Now, can someone tell me what is the signal used for read address channel? What signal is used for read address channel? AR. What signal is used for write response channel? It is B. So that basically that knowledge, that things you should remember. Next, how
Sir, why
handshaking?
name given is B?
Sorry,
Sir, why name given is B? It is a
what do you think we
response,
should give?
then
Tell me. No, tell me.
uh,
What do you think we should give? What name should we give?
it can be response. Yes, sir. Yes, it is. AR is already occupied.
Yeah. Uh, takes a channel handshaking. Handshaking is required whenever two components doing any sort of communication, right? If there is any sort of communication happening, handshaking is required. Initiating component indicates that I am giving information. The receiving components indicates that I am ready to accept the information. See, basically, one component says I am giving information, other component says I am ready to accept the information. So, since there are five channels, understand, since there are five channels, how many handshaking signals are required totally? Can you tell me? How many sets of handshaking signals are required? Okay. Since there are five channels, for each channel requires a dedicated valid and ready signal for handshake. There will be dedicated valid and ready signal. In total, AXI has five sets of handshaking signals. So tell me, valid and ready are the names. For write response channel, what will be the handshaking signal names? Can you tell me? For write response channel, for write response channel, what is the handshaking signal names? Will be valid, be ready. Simple. For similarly for read address space, what will be the handshaking signal names? Can you tell me? AR valid, AR ready. So in total, AXI has five sets of handshaking signals. Initiating component drives AW valid equal to 1 at positive edge of clock. Indicate that indicating that component is driving valid information on write address channel. See, AW valid is corresponding to write address channel. In response to this, slave drives um, AW ready equal to 1. So indicating that I am ready to accept master provided information. Whatever information master is providing, slave is indicating that I am ready to accept the information. Tell me, one question I want to ask is, does AW valid and AW ready handshake indicate that right transaction completion? Tell me. But let's say if I say that AW valid and AW ready handshaking has completed, does it indicate that right transaction has completed? No, right? It won't indicate. Okay, it will only indicate that right address space has completed. It only indicates right address space has completed. Going back to the bank analogy, It's like telling whatever application you have given, bank acknowledged acknowledged that it has received. Does this mean that home loan complete process has completed? Does line number 71 indicates that home loan complete process is completed? No, right? It only means that you started with application process. Like that for everything you do, even when you go to bank for submitting document, they will give you acknowledgement. Again, giving data doesn't indicate that your transaction is complete. It only tells that that data phase has completed. Okay. At any positive edge of clock, if both AW valid and AW ready are 1, it indicates that completion of the address phase. Right address phase. Right address phase. Not the entire transaction. In that case, same question will come. Let's take same question. There are 4 handshaking possibilities. You are all clear with the 4 possibilities, right? You are all, you know, right? Valid is 0, ready is 0, valid is 1, ready is 0. That combinations you know. Okay. So I'll go to the next slide. Okay, these are the different possible handshaking illustrations. Please take a look and tell me, what do you understand? What is the difference? I want you to go through these 2 diagrams and tell me what is the difference you see in these 2 diagrams. Yeah, can you tell me what is the difference you noticed in this example, these 2 diagrams? The difference is, in the first case, ready is slave was not ready. The receiving component was not ready. So once you gave valid, it took almost like more like a 2 cycles to get the handshake, to complete the handshake, because ready was low. In the second case, ready was already high. So as soon as you gave valid, very next clock cycle, a handshaking happened. So that's the difference. So transfer is complete when both valid and ready are high. So here basically what happened is, uh, ready is not high, ready is low initially. Hence, the handshake got delayed by 1 clock cycle. Do you agree with that? It got delayed by 1 clock cycle. Whereas here, the ready is already high. Ready is already high. Ready is already high. Hence, handshake completed in same clock cycle, in very next cycle without any delay. Clear, right? This point, everyone? So it's good to keep the ready high before itself so that your handshaking gets over quickly. So that is the reason in some protocols you will see that they'll keep ready by default high. To save this clock cycle, some slaves will keep ready high. Yeah, that is what, right? Ready and valid are high at positive edge of clock. That is when the transaction completes. Here also, this is where the transaction completes. So what is your question? What is your question, Monica?
Sir, these lines, sir, in second diagram, when the positive edge of clock is there, then valid and ready are high, but a very small instant is there. That's why.
No, no. That is fine. See, once they became high, then after that they can be dropped. That is not a problem. But if you see at passage of clock, both of them are high. Is that clear?
Yes, sir.
Okay, sure. Now this is just a brief about how handshaking happens. Please read this once. Very much. I mean, this is very obvious things. Just go through this once, please. Based on this, let me ask you some questions. What is the direction of AW valid? Who drives AW valid? Can you tell me? AW valid is driven by whom? Master or slave? Its output to the master. In response to that, slave gives AW ready. So slave drives it. Tell me. B valid. Who drives it? B valid is driven by slave because B valid corresponds to write response channel. Write response channel is done by the slave. Hence, B valid is given by slave. Then who gives B ready in that case? Master. Tell me, who gives R ready? Who gives R ready? So you have to ask read response channel, right? Read data channel means what? Response will come from the master. Because data is given by master, sorry, data is given by slave. Ready will come from the master. That basic understanding you need to have. I hope you got this. Next. These are the various signals in the write address channel signals and read address channel. Let's go through this ones. Please read it and read the basic description. For now, don't read this. Okay, for now, don't read below this. Read only till this point. Other things I'll explain you later. Don't read these three. Okay. AW lock, AW cache, AW protection. Don't read. Other things you read. This you please read. You should be able to understand easily now. Please read through this and let me know if you have any questions in any of these things. Okay. So what is AWID? This is an identification tag for write address group of signals. It's like application number that you use for entire transaction. So all this information will be mapped to AWID. Okay. AW length, burst length. AW size is the burst size. AW burst indicates the burst type. AW valid and AW ready are the handshaking signals. Similarly, we have write data channels. WID, W data, write strobe. What is write strobe? I'll explain you as we go forward. W last indicates the last transfer in the burst. That means what is W last? If you go here is, if this was the last transfer, for example, data 4, W last will be low till this point. Here it will be made high, indicating that this is the last transfer in the burst. How many transfers are there totally? What is the given this? Can you tell me what is the burst length in this example? If this was the last transfer, what is the burst length? 4, because 1, 2, 3, 4. It's Sandhya. It is not bytes. It is 4. Bytes is the burst size. In each transfer, I am doing, let's say, 4 bytes transfer. So 4 byte is the burst size. 4 is the burst size. In each beat, if I'm sending 8 bytes, so burst size is 8. Did you understood, Sandhya, what is the difference between burst length and burst size? So burst size is in each data one, how many bytes you are sending at once. Here also you will send the same. Here also you will send same. Here also you will send same. Okay. Burst W last will be high here in the last beat. These are called as beats. This is beat 1. This is beat 2, beat 3, beat 4. So totally how many beats are there in this? Burst length is 4, means there will be 4 beats will be there. W valid and W ready, See, if you are doing same transaction, this WID value should match exactly AWID value. WID value should match AWID value. That is how they use the identification tag. Then you have write response channel signal. You have BID, B response, B valid, B ready. So BID is again response ID. See, this will tell for which transaction this response corresponds to. It's like, for example, 10 people applied for home loan. One sanction happened. How do we know among these 10 home loans whom does it corresponds to? They will check what is the application number for which the loan got sanctioned. So there they will check among these 10 home loans which application number does it match. The same is the concept of BID. B response indicates the response, different types of responses. Is it a correct response, error response, or decode error? Different types of responses. And valid and ready, are for handshaking signals. Similar to this, so now this is how the write transaction looks like. You see, write address phase, multiple write data phases, write response phase. Tell me, what is the burst length in this case? If you see this diagram, what is the burst length? how many times data phase is happening. You can see the numbers A0, A1. Burst length is 4. 1, 2, 3, 4. Who gives this information, AW address and AW valid, master or slave? Master. Who gives all this information again? Write data, write last, write valid, everything. Master. Who gives this information? B response and B valid? Slave. So putting together all of these is what is the right transaction. Putting together all of this into one place is what is the right response space, right transaction. Next. Similar to that, in AXI also, a read also has the same set of signal: AR ID, AR address, AR length, AR size, AR burst, AR lock, AR cache. Some signals, let's not get into it. These signals have same meaning as write address channel. Then you have read data and response channel also. Let's talk more of this in the next session. Okay. So we will stop here. Any questions before we